Welcome to this new section dedicated for learning about the structure of a C program when there are more than one function in a single program and when there is more than one file in a program. Okay, as of now we have only learned how to create a program having a single .c file. In this section we are going to learn how to create a program having multiple files. Okay, so this section is dedicated for learning about the structure or the layout of a C program whenever there is one or more function and whenever there is one or more file in that particular program. We're also going to have some lectures on local and global variables. Okay, and most importantly we're going to talk about storage classes. There are 4 storage classes: automatic, auto is the keyword for representing the automatic storage class; external, extern is the keyword; static, static is the keyword; and there is a register storage class. Register is the keyword for the same. So in this section we are going to learn about all these aspects related to the structure of a program. In this lecture we are going to learn about the local and the global variable. Now, as the name suggests, what do you mean by local? Okay, local is something that is internal to the function. Okay, and global is something which is external to the function. Let's say you're having a function. Okay, all the variables that is defined inside the function, also called as the internal variable, all these are local variables, meaning these variables are only accessible to that particular function and no one else. But whereas the external variable or the global variables are globally defined, it is defined outside of the function, so it is accessible to all the function that is being defined below it. Now let's try to understand the local and global variable in more details by taking this example. So in this example there are 2 functions as mentioned here. The first function is called as foo, okay, which takes one integer argument and returns nothing. Now there is one more function, the main function, which has one variable c. Now let's talk about the variable a and variable b. A is the argument and b is a variable that is being defined in this function. Now both of these variable a and b are local variables. Okay, so whenever this function is called, the variable a, let's say this is the variable a, okay, this box is the variable a and this is variable b. Now these variables are only accessible to this foo function. Only foo has the access of variable a and variable b. Similarly, inside the main function there is a variable c. So let's say this is a variable c. Only the main function has the access of the variable c and no one else can access the variable c. Okay, now for example, if I try to access the variable c from the foo function, this is an invalid statement because c is not available in the foo function. Okay, c is only accessible to the main function. Similarly, if I try to access variable a and variable b from the main function, I cannot do that because variable a and b are local to the foo function, so therefore it is not available to the main function. So this is local variable. Local variable will have its own specific memory allocated for it, and that memory location is only accessible from the function where it is being defined. So therefore b is only accessible from foo and a is only accessible from foo. Similarly, c is only accessible from the main function. This is how local variables are defined. Now let's say I would like to define a variable that is accessible to both of these functions, foo and main. So now I need to have a variable that is externally defined. Okay, that must be external to these functions. So if I want to have a variable accessible by both foo and main, I'll have to define a variable outside of foo and main. Let's say the variable name is x, so I write int x. So this is called as the global variable. Okay, global meaning now this variable is accessible from the foo as well as from the main function. Okay, so let's say this is the variable x. Okay, now this is the variable x. Now this variable x is also accessible to the foo function and this is also accessible to the main function. So therefore whenever the variable is defined outside of the function, it becomes the global variable. So that is accessible to all the functions that is being defined after the definition of that global variable. Okay, let's say I define one global variable y here. I write int y after the definition of the foo function. So in this case what happens is now y is not accessible to foo. Okay, in this case the variable y is only accessible to the main function, okay, and not accessible to the foo function because the definition of main function is after the definition of the global variable y. So this global variable y is not actually global. So if you want to make a variable really global, that means if it needs to be accessible by all the functions, make sure that you define that global variable just after your header files at the top of your code. Okay, so this is how global and local variable works. Now let us try to demonstrate global and local variables by writing a computer program. So in this program there are two functions. The first one is the foo function, takes the argument a. So a is the variable local to foo. Okay, similarly b is a variable that is local to foo. So these a and b variables are local to the foo function. And there's one more function, the main function, which has one variable c. Now variable c is local to the main function, and at line number 17 I'm making a call to this foo function here. So this is a function call happening here at line number 17, and globally at the top at line number 4 I've defined a variable x. So x is a global variable, so x must be accessible in the function foo as well as in the function main, because x is a global variable. Now let's try to access the variable b in the main function. So in the main function, let me try to, after this function call, let me try to make a printf statement here that prints the value of b. So b equals to %d. Let's see what it prints. Okay, because b is a variable local to the function foo, it should not be accessible from the main function. Let's see what happens. Let's try to compile this code. Okay, so if you see here, it says that there is an error in line number 18. While accessing b, it says that b is not declared, undeclared identifier, right? Because b is not available in the main function. B is only available in the foo function. So we say that variable b is only local to the foo function. Okay, if you scroll up, there is one more error here. It says that there is too few argument to the function foo. If you just look at a function call of foo, right? Foo actually demands you to send an integer value. Let me send 10 here. Okay, and let's compile this again. So only there's one error is there, that is b is undeclared. Okay, now the function call is okay. So this is the concept of local variable. So this is not accessible, so I'll just comment this out. Okay, similarly you try accessing c from the function foo, it will not be accessible. Okay, now let's try to access the variable x. Now x is a global variable. Let me try to print the variable x from the foo function. So this is the foo function. Okay, so x equals to %d. I'm trying to print x from the foo function. Okay, let me see what does it print. Because x is defined globally, you should be able to access the variable x from the foo function. Okay, so let me try to compile this, run this code. So it says that in the foo function the variable x is equals to 0. So x was not assigned any value, right? So always remember, any global variable is by default assigned the value 0. So x is a global variable, it automatically takes the default value 0. So initial value of x is 0. Therefore, in the foo function, the variable x is equals to 0. Similarly, let me try to copy this code and put it in the main function. Okay, after I make the call to the foo function here. So let me print this in the main function, the variable x is equals to x. Okay, so let me try to compile this now, run this. So you see, in the foo function, x is 0, and in the main function also x is 0. Okay, you can very well actually define this globally, the variable x. So you can write int x. If you just write int x, it will be by default 0. But if you write int x equals to 11, now it will be globally treated as the initial value as 11. Okay, so let's try to compile this and run this code. Now you see, it is 11 at both foo as well as in the main function. Let me try to update the variable x from the foo function. Okay, so now in the foo function, after I print x, I'll just write x plus plus. So I'm update global variable. Okay, I'm updating the global variable from the foo function. Let's see what happens to this. Okay, so now let me make a copy of this here. Okay, before I call the foo function, let me print the variable x here. Okay, so this is in the main function before foo call. Okay, and in the main function, this is after foo call. Okay, so in the foo, I'm trying to update the value of x. So I'll just write printf value of x updated from foo. Okay, I'm just printing all these messages so that we can see what is actually happening there. Okay, so let's try to save this and compile this code, run this now. Okay, you see, first of all, in the main function before foo call, x is 11, right? Initially the value of x is 11, so that is printed here. Okay, now after this it is calling to the foo function, so the control will pass to the foo function. So in the foo function, x is printed here. So x is printed from the foo function. So x becomes 11 because x is not changed as of now. After this, x is updated. Now x becomes 11. Now it will become 11 globally, right? Whoever accesses x, now it will be getting the value of x as 11. After that, I print value of x updated from foo. So the value of x is updated from foo. Now the control gets back to the main function. So control will go back to this line number 21. It encounters line number 22 wherein I'm trying to print the value of x. So here now if I print x, now x becomes 12. Okay, in the main function, after foo call, x has become 12. So this is how global variable actually works. If you see here at line number 18, c is a local variable in the main function. So let me assign the value to the c as 21. So c is assigned the value 21. Now let me try to print c. Okay, c equals to %d. Okay, so this is c. I'm printing the value of c. And let me just try to comment this entire thing here. Let me compile this. And you see the value of c is 21. It's working fine. Okay, now what I can do is I can open a block here. This is allowed. Okay, so whatever comes between the curly brace is called as a block. So this is a block. This is a block. Now what you can do is inside a block you can actually define a variable. Okay, so here I can define any variable. I can also define the variable c. So if I write int c and if I make c as 32, let me try to print the value of c here. Print f c equals to %d. Okay, let me print the variable c here. Okay, so this is inside block. Okay, so this is c inside main. Okay, now let me try to print the variable c after the block. Okay, so let me just write here inside main. Okay, after the block, c is this much. Inside main, okay, here before the block, c is this much, and this is the block. Now inside the block I am actually defining the variable c one more time. So now it's very important to understand that the variables, local variables, have something called as a block scope. So scope of all local variables is limited to the block. Okay, that means it is only available in the block, not outside of the block. Okay, now if you see, this c is defined in this block in the definition of the main function. So the block starts at line number 16 and ends at line number 35. So this variable c is accessible to all the places, all the statements inside this block, but this variable c is only accessible in this block, Okay, now let me try to print what happens. Let me try to compile this first and then run this. Okay, so if you see here, what happens initially here is, as it is predicted, c is 21, so it will print inside the main before the block c is 21, which is printed correctly. So here I get c as 21. So that is fine. Okay, now I get into the block. This is a block. Inside this block again, c is a variable, so I can define a new variable inside a block. So the scope of this variable will only be this block. Now whenever I refer to c inside this block, it will refer to this c and not this c. It will always look at the definition that is closer to itself. Okay, so whenever I write int c, c becomes 32, so it will encounter this one inside block c equals to 32. So in this case, c would be treated as 32. So here 32 is displayed. Now once this block ends here at line number 27, the block ends here, right? So once the block ends, this c, the memory of this is lost, so it is not there in the memory, so it is not accessible outside of this block. So outside of the block, still this c is accessible, 21, right? So here inside main, after the block, you see the value of c is 21. So in this case, the value of c is 21. Okay, so this is what you mean by the block scope. So scope of all local variable is limited to the block where it is being defined. So in this case, foo, this is the block, right? So this variable b, the scope of this variable b is limited to this block itself. It will not be visible or accessible from the block outside of where it is being defined. So this is what is called as the block scope. But the global variable is globally accessible. So it is accessible. The scope of this global variable is available throughout the program. Okay, in all the places this global variable is accessible. Okay, all the functions that is being defined after line number 4 can have the access to the variable x. So it is global in nature. So this is how the global and local variable differ. Okay, so whenever you are writing a program, if you need to share a single variable in multiple functions, In that case, you can make use of the global variable. Okay, so that's all in this lecture. I hope in this lecture you have understood the working of local and the global variable. Stay tuned.